Yeah. Okay. Hi, everyone. Thanks, Rob. Thanks for the warm introduction here. So hi, everyone. I'm Amit Mookerjee. I'm a product manager at Meta. I work in the Instagram ads business. Really excited to be here. And with me, we have our performance and capacity expert from the Infra team at Meta. So the Infra team actually builds and operates one of the largest private cloud platforms in the world. And today, we are really excited to kind of share our journey of adopting FinOps. Specifically, we're going to talk about applying FinOps principles at the data center and driving it all the way up to driving value at the product level, which in my case is Instagram business. So I'm going to talk a bit about what we presented last time in FinOps X 2024. This was where we talked about our journey of FinOps. This actually started 2022, when it became very obvious to us that we really needed a very good understanding of how much we are spending and what business value that spend is driving. We didn't have that before that, right? So that kind of kicked off really a series of things which kind of translated into us being what we call FinOps capacity planning at Meta. So at a high level, what does FinOps capacity planning look like, right? So you have the products, Facebook, Instagram, WhatsApp, used by billions of users a day. They actually run on top of the private cloud platform that Lou and his team kind of operates, right? So there are platforms, compute and storage, inference and training, all the platforms that you would expect in a public cloud. We have the same platforms over there. So what these product teams do, they kind of do their bottoms-up forecast for these platforms. Then these are reviewed. We have finance budget limits. We have infrastructure constraints. We may ask for a lot of different capability resources, but we may not. We may be kind of limited by what's available. And then we make ROI-driven decisions, right? Like we will not prioritize everything that folks are kind of want to work on. Then we do a leadership review, and this happens like once a quarter. And once there is an approval of the plan, it kicks off the ordering process of actually getting those servers in, hooking up all this, turning up this new resources for use by our teams. And in my case, it is Instagram ads. So today, we're going to go a lot deeper here, right? So kind of this loop that we're kind of talking about, there's a lot goes in here, right? And one of the things when we kind of started thinking about FinOps capacity planning at the scale of Meta, it became very clear that we needed a very robust cost metric with a certain set of attributes. So one key aspect of it is really comprehensive cost understanding. And the cost could come from procuring servers, building a data center, the land actually on which the data center is built, network cost, and also the personnel who are operating that infrastructure. So we needed to cover all these dimensions of the cost in the metric that we're kind of working with. Then we wanted to do ROI analysis. ROI in my business is really, it's the ads revenue, it is dollars, and I is the cost, the infrastructure cost, right? And in other cases, it could be like engagement metric. It doesn't have to be dollars in every case. But we wanted to do that in a very thoughtful, data-driven way. The other aspect of the metric is we wanted to have the ability to trade off investments in capacity and headcount. There are some projects that require more capacity and less headcount, and vice versa. So we wanted to have the ability to make those kind of trade-offs. Also, efficiency is plays a pretty big part in this whole picture as well. Infrastructure is one of the biggest spends at Meta. You can look up our balance sheets over there. There's billions and billions of dollars. So it's very imperative for us to use that infrastructure in the most efficient way as possible. We have a company-wide efficiency program to optimize the resource usage. So we wanted those efficiency programs to be captured in that cost metric as well. We also needed operational flexibility. We live in a very dynamic business environment, and we wanted to adjust if things change. For example, a few months back, we never thought about tariffs as a thing that's going to change our plans. Now we do, right? And we needed to make those adjustments. So that metric needs to support that kind of agility. Lastly, we needed granular reporting, all the way from answering a question that, hey, how much does it cost to run Instagram as a whole, reels or feed, to answering a question, hey, if you're putting up a data rack in a data center with GPUs in it with liquid cooling, how much does it cost? So we needed that kind of understanding from the top at the granular level to the data center level. So with that, we actually came up with a metric we call OpEx at Meta. And I understand, Lou, that the journey of building out OpEx at Meta started with ice cream. Can you tell us a little bit about that?
Yes, thanks Amit for the introduction, the opening. Hello everyone, my name is Lou. And funny fact about this is, this project is actually born as a hackathon project back in about 3 years ago. The idea came up when I was having ice cream. The idea was, what if we are moving out the Meta's infrastructure and capacity team and form a standalone cloud company? By doing that, it probably make it the world's fifth or fourth, even third largest cloud company automatically, depending on which year we're talking about. And what's special is this company will still providing cloud capacity to Meta and only to Meta. In this case, there are also some special string attached to it. Basically, this company will now try to make profit out of Meta, but also is not trying to take any loss. Means Meta will pay everything for it. So in this case, how much this company should be charging Meta back is what to think about. So in order to do that, right, the first thing to do is this company has to tell Meta what kind of resources it's providing and how much do they cost. These are just dummy numbers from the internet, but the idea is just like every cloud company that it has to tell its customer what it's offering and what's the rate. In our terminology, we call it rate cards. And I just learned recently that there's a word here called unit economics, which basically represents the same idea. And with that in place, still the fundamental question is how to provide capacity. And I'm here just to use the most simple way to do that, to describe that, in a way just like how to put elephant in the fridge. Now let's first open the door. So first, you need to buy servers, right? Servers basically computers, and you need to buy a lot of them. And they are normally placed in a big shell called rack. So servers are really the foundation of any cloud service, which is the physical existence, right? And for all the cloud services, they will either directly or indirectly running on physical capacity in the end. So with server spot, you need to place them somewhere, right? Not in your garage, something proper, right? So you have to build a massive building to place them, which is data centers. And building data centers and planning take many years. And the speed Meta building data center always never catch up with the speed we are requesting capacity. Some funny thing is that in the early days, Meta even leased data centers from others. Also recently that we even built some temporary data centers, we call them tent, actually just to deal with the rapid capacity growth. Okay, now we have the servers, we have the data center. Next thing is to power them up. Otherwise, they are nothing but some really expensive metals, right? So I assume there are some Star Wars fans here. So take a guess, which Star Wars character will be the easiest to find a job at Meta?
Any guesses?
Let's count to 3, 2, 1. Okay, that would be Sith Lord. Because he can produce high voltage electricity from his bare hand, right? Imagine how useful and how much impact he can produce for Meta. The reason I'm mentioning power is that there's so much power needed, right? If you look at the newly announced data center by Meta in Louisiana, the single data center will provide 2 gigawatts of compute capacity. And 2 gigawatts is enough to power 2 million homes, right? And if you read the news actually came from yesterday that Meta just secured a 20-year contract with a nuclear power company. And it's pretty cool, right? But if you look at the number, right, that massive nuclear power deal only provide 1.2 gigawatts, which can only power half of it, right? Where do we get the rest, right? Just to give you an idea that how much power we'll be needing to power all the servers there. So next we have the server life, and next thing will be network, right? Network is really complex, and if you've been to the data center, you will see literally millions of wires running there, and I'm always amazed how well they are organized there. It's like most people are so organized, and that's just the visible part. There are also layers of different network behind what's visible. For example, right? Meta also announced under ocean cable build plan, which costs billions of dollars. And I hardly imagine I can see them with my bare eyes, but it's there. Okay, next thing to worry about is cooling. We talked about how much power, electricity running for the servers, and they will produce a lot of heat. If you've ever been to a data center, either the small ones that is maybe hidden in the office building, or like proper data center, you always notice two things for sure. One is they are either super hot or super cold. And the next thing is really loud. The reason is like with so much heat produced by running these servers, if you don't deal them properly, those servers will literally melt like a chocolate fondue. And like there will be fires, not the fires that you're dealing with in the data like SEP 1, SEP 2, but literally there'll be fires burning in the building. So it's really crucial to be able to handle those like heat. That's why those environment is not really designed for human to be comfortable, but designed for the servers to be comfortable. Okay, now we have the bare metal environment there. The next thing for this cloud provider to think about is how to make the server do some job for customers, right? And how to make it as easy as possible. That process is called capacity abstraction or virtualization. It benefits customer a lot by having the standard capacity offering and the deployment of job very easy. It just makes their life much easier. But think from the other end, right? It actually makes the cloud provider's life much easier as well. Because if you think about it, right, when there's a new hardware released, those cloud providers will not immediately decom or resell or shred their servers all the way, right? Normally, there will be a mix of generation of hardware running in parallel there, like you bought this year, last year, before. So in this case, being able to abstract the customer offering with actual underlying hardware is actually crucial to make capacity management much more flexible, scalable, and efficient. Okay, before I hand over this magic button to Amit, I want to talk about shared services. If you think about it, right, almost every customer needs those kind of similarity of services that everybody needs relational database. With big data, everybody will have to store their data in data warehouse, like data lake and cold storage. And with AI, everybody needs training inference platforms. And you think about FinOps, right? I actually consider FinOps a special kind of shared services, where it's helping like all the customers to do their financial operation planning, which is a unique type of shared services. Okay, with all this in place, Amit, can you tell us more that how does this even matter to the product side?
Sure. Well, this is kind of mind-blowing, right? Like data centers in a tent, that blows my mind. But that's what we do here, right? Like kind of the paradigm of moving fast at Meta. So let's kind of take a look at how we are kind of putting all of this stuff together, right? So at the lowest layer, what Lou talked about, we have the data centers, servers hooked up to the internet, and that's kind of an industry problem. That's the infrastructure as a service. So we have this, interfaces that are exposed on top of it. On top of that, like we build those applications, right? Databases, data warehouse, AI platforms, which use those abstractions built on top of it. And then on the top is where we stand, right? Where all the applications that you are familiar with, they basically are built on top of those shared services in here. Now, this gives you the complete picture of how, when we think about like capacity planning as a whole at meta-wide scale, it goes kind of, hey, there's the apps, there are the shared services, there are abstractions over there, and then there's the physical layer. So any kind of scaled out kind of capacity planning that we needed to do needs to account for everything. So this is a FinOps conference. We're going to talk a little bit about finance as well. So let's talk about CapEx. What is CapEx? This is the upfront cost of purchasing assets. The asset could be a piece of land on which you want to build a data center, could be servers, could be network infrastructure, but this is a one-time cost. But each one of these assets, they have a useful time period. So a data center has usable life is several decades. A server lifetime would be 5 years or 7 years. So to kind of get a true representation of the cost, we needed to, in the finance term, amortize the cost. It needs to be depreciated over the usable life, right? And that's what is the starting of really understanding what OpEx is, right? So you have these things, all the costs that you're getting, from these different elements like server, network, data center, and amortizing that over its useful life. So to get into a little more detail, right? So if you look at like a slice of how it actually looks like. So if you look at the server cost, there is a variable overhead and a fixed overhead. So variable overhead could be like taxes, license fees, general and administrative costs. Fixed overhead could be new product introduction, support and maintenance. For data center, it could be electricity, rent, some variable labor cost, and fixed overhead could be like, data center design, the labor required to actually build that, and so on and so forth. Like there are kind of a lot of different kind of aspects to it. Now, you can see that there's a lot of different elements to it, right? Like you can see for even like one type of resource, this could be like tens, if not hundreds of line items that kind of contribute to kind of come up with the unit cost of running a resource. So let's take an example, right? So let's say we have the web compute unit, right? You want a unit of a web compute unit. It kind of gets broken down into all of these different pieces. There's a data center piece, there is a foundation, infra management network, and each one of them has its cost and also personal cost, right? Which are kind of involved in it, right? So we kind of put all of these different pieces together, and then you arrive at the unit cost of a web compute platform. The amazing thing is that actually Lou and his team actually did this exercise for hundreds of platforms that are supported on our private cloud, right? And they have, like, we have this kind of really fine-grained cost attribution, which really kind of is a game changer for us, where we can actually, having this kind of level of understanding of the cost actually enables a lot of interesting things to do that we're going to talk about a bit later. But again, in principle, this looks kind of easy, right? Like putting up all of these stuffs together, summing them up, attributing it, how difficult it could be. But I understand you face some challenges, right?
Yes, and I know everybody like to hear about the exciting part of the story, but here I still want to touch a tiny portion of the challenges we've been seeing out of the million challenges here, because I don't believe that we are the only one who have been thinking about those problems. First challenge I want to talk about is the service dependency. Let's use some examples there. Let's say we have the physical capacity, compute type 1, compute type 2. We call them leaf node or terminal node because there will be no outgoing edges from it. And then we have service A and service B, where B depend on some leaf node 2 and service A depend on leaf node 1 plus some portion of B. In this case, in order to for this unit economics, for understanding the unit cost, right? B is quite simple, right? It's just the 10 leaf node 2 add up together. But for A, should we only charge for the physical capacity it's using? No, it's right, because in order to provision one additional unit of A, we actually need provision those leaf node plus some B. In this case, the total cost for A is actually them add up together. And that's just a simple case there. But in the real world, right, they're not always like that. We have, like, for example, A depend on some leaf node plus B, maybe B depend on some leaf node and C go back to A in the graph. And there are hundreds of them, right? In this case, how can we really understand the unit cost of each of the service there? So in the ideal case, we want the formula to be represented without other services there. In this case, it's going to be A, B, C represented by leaf node only. And we call this exercise a flattened process, which will be treating the leaf node as a symbol. And then we want to change the formula until it only have those leaf node with some coefficient that still go back to the original relationship. How to do that, right? So it really become an interesting mathematical problem here. The first way to do that is through iterative nesting and pruning. Basically, we'll be taking and substituting the other formula to one repeatedly, and this formula will grow bigger and bigger. In this process, we will be aggregating the coefficient of the same variables there. We'll do that repeatedly until the coefficient of other service become small and negligible enough to be pruned. The second method is through the system of linear equation. We basically will first encode the relationship in the matrix, which contains both other services and leaf node, and we throw it to some magic solver. The solver will tell us another matrix where the coefficient will only be existing for this leaf node. Both of them has pro and cons. We're using them both. The second approach is deterministic, means you only get one result no matter what you do. And it's really helpful for solving all the services in once, but it's expensive. While the first approach, sometimes that when we have already an existing relationship and we're only modifying some of the formulas there, in this case, we might only run this individual ones. So the first approach will be much flexible and interesting. So we're taking both and use them for different use cases, and yeah, we build solution for both. The next challenge I want to talk about is the tension between the pricing scalability and accuracy. So we are really in the planning world where we are doing 5 years forward looking. That by doing that, we have to take the forecast of product demand, we'll take the forecast of capacity plan, the financial plan, and we really don't have the usage data or ledger for them yet. In this case, we're actually doing our best. If you look any future time, right, there'll actually be multiple versions of price we generate. There'll be multiple forecasts, and then there's actual cost for it. During this process, we'll get more and more accurate data, with more accurate data start to pop up. But that's what we can do to measure the real-time cost. But from the customer perspective, right, they don't really like that, because nobody likes unpredictable things. Especially when the product team may already define the dashboard for tracking their usage, tracking the budget, tracking the efficiency. If there's a changing factor there is out of their control, it really makes their tracking inactionable. So in this case, we actually have conflicting requirements that product wants stable price, but infra and finance want more accurate cost. If you look at the cap theory in the computer science world, right, there's a impossible triangle where consistency, availability, and partition tolerance cannot be satisfied at the same time. You can only optimize your system to achieve two and sacrifice the third one. We actually have a similar situation here, where we have the requirement for providing stable pricing. We also have the requirement to provide the real cost, but we also have this special requirement that there's no profit loss for this, right? In this case, after months of debate and discussion, we actually think choosing the constant price, actual cost both is a good idea. Basically, we'll be running a dual rate card there, where we will have a stable price for budgeting, cost attribution purpose, because that's what the capacity contract is established. But in the meanwhile, we're providing the actual cost for efficiency measurement, for fulfillment, that is reflecting what is the actual cost underneath. But implicitly, we'll be sacrificing the no profit loss assumption there, which also creates some interesting questions. For example, when there's a delta observed from the actual versus contract, so whether do we do some true up, right? And when the delta is big enough that maybe we are selling this resource for too cheap or too expensive, what's the cadence or run book for changing that for exception? Also, whether we should have some incentive system, for example, IG team did an amazing job for the efficiency and use less capacity than they're already thinking. In this case, whether we should implement some incentive for them. These are all the questions to think about. The third challenge I want to talk about is allocation precision. If you think about it, right, this process is nothing but cost allocation attribution. Means we're allocating finance cost onto hardware, and then attributing the hardware cost onto customers. So the first challenge to see is that how to define the cost for capacity. Because the whole company reports cost, but not everything is spent on capacity. In this case, we actually have to work with finance team to study the ledger and understand what exactly cost will go into this capacity pool. And some costs are pretty trivial and easy to understand. For example, the depreciation, like DC, those things are easy, but there are some gray area where, for example, the whole infra team has more than 10,000 people, but not all of them work on capacity. In this case, we actually have to come with some magic number ratio to kind of allocate this by look at each person's job title and determine whether the profile is working on capacity. With that, we actually have a pie. That next step is to slice the pie. So next question is, which hardware will burden which cost, right? Because not every cost should go to every hardware. We actually recently received this interesting inquiry from customers that they come here and say, hey, I'm using the capacity and I know that there's a breakdown of all these items where cost is being charged for. I see there's a liquid cooling, but my hardware doesn't use liquid cooling. Why, right? So in this case, right, we just realized that we're allocating the future like liquid cooling cost to everybody by a default ratio. But if you dig in deeper, it's because that Meta is building a new type of data center which will be supporting liquid cooling, because the traditional heat sink and fan methodology will no longer work for the AI. We actually will build like pipes and hoses next to those racks, just like a plumber space that deal with the cooling. So in this case, they are really expensive. So we actually carefully studied how this cost will happen, that we realize that only a certain type of hardware will be attached to this liquid cooling. In this case, we can optimize our allocation strategy to make sure that only those liquid cooling costs go to those hardwares. The third thing is how to make sure that relative costs attributed to this hardware are fair. For example, electricity. Electricity is pretty obvious that it will go really well linearly with the power rating of the rack. In this case, we will be allocating the electricity bill by the power rating. Similarly, we define a bunch of different kinds of weight so that we can more properly mimic how in the real world this cost will scale up by different factors. The last thing I want to talk about is visibility, explainability, and enforcement. I actually believe that most of the world experts for this topic is actually here in the FinOps now. First thing is visibility and observability. The question is, so this whole system takes a lot of input by different dimensions here. When something changes, the whole system may change. For example, we might be changing our server useful life. We may be changing our power rating of the rack because our workload has been changing. And our platform dependency may be changing. With all of this happening, how can we explain to customers why things are changing? In this case, having sufficient data point, being able to do that is crucial, because nobody will trust you if you don't provide the explainability there. The next level is self-explainability there, which is like, we have all the data there, massive data, but not every customer is able to understand them, and you cannot expect them to do that. In this case, there may be me, maybe a few others who know this data can help customer to understand the questions once in a while, but it's really a time-consuming and non-scalable exercise. In this case, the ideal case is we have some dashboard and metrics that can help a 95-year grandma to understand the problem by herself. And I think that is a really challenging problem there. The third thing is enforcement and governance. So we have all the observability and explainability. How can we make sure that we are taking proper actions as a guardrail to proper capacity operations? Also, there might be changes happening. For example, the org chart may be changing, which will automatically change the customer attribution. Also, there might be capacity transfer, capacity exchange. When all those things happens, how can we make sure that we're allocating capacity to the right customer? In the end, the capacity is a zero-sum game, right? If some customer take more capacity than they're supposed to, then somebody else will maybe starve. So I'm just here to talk about those challenges because I think it might be very common for a lot of people here. And okay, now I want to share, Amit, can you share a bit more from the user story perspective? How can this even enable the customer?
Sure. But before we get into that, right, I want to call out, we talked a lot about OpEx here, the model that we have built, which is very important. And we're going to talk about how we use it for business planning. But that's not the only thing. There are a bunch of other metrics that we care about as well. So we want to call that out. CapEx, we talked briefly about CapEx. That's still very important. It's a pretty big determinant of financial planning, cash flow analysis. So we care about that. Plant power. Plant power is very important. The plant power is actually a big constraint into how we can scale up our infrastructure. You can have all the resources, you have the finances, but if you cannot get the power, you're not able to scale up the way you would want to be. So before we actually adopted OpEx as a kind of a key metric, we actually used planned power. Now, planned power had some limitations. You remember those kind of the 6 attributes we're kind of looking for. It didn't have that, but it was still important. But this is also something that we still kind of look at because that's a determinant in how easily and how well we can actually scale up our infrastructure. Finally, carbon emissions, right? So we have a sustainability goal. We want to be net zero by 2030. So Meta has set that goal. And we measure the carbon emissions from our infrastructure as well. This is very key so that we are on track to meet our sustainability goals as well. So with that, let's kind of switch gears into how we use OpEx for business planning. And I'll take an example of my business with the Instagram ads. So broadly, like this is the way the kind of the planning cycle works. So you have a long range planning cycle. We look about 4 years in advance. We look at like the growth that we are getting, some new strategic initiatives, and kind of make up a plan of what kind of budget that we would need in that kind of time frame. Again, the key unit over there, we are given budgets in OpEx dollars. All the planning happens in OpEx dollars. The long-range plan kind of, after we kind of finish that, it kicks off in ordering cycle. Really, it takes time to procure capacity. In some cases, it takes up to 9 months to actually procure capacity, right? So you have to order them a lot in advance. So depending on kind of the outcome of the long-range plan, we get the orders in place. Now, then when we actually come to the execution phase, right? We do like 6-month phase, half-phase planning, and right now we are actually in the planning phase, where we do more detailed kind of bottoms-up estimation of what actual capacity you would need to deliver the incremental value, the business value that we're looking for in our case, which is ads revenue. So the teams kind of do that. So again, they have constraints. There is a budget that is set as a part of the long-range planning process. There is a capacity envelope that teams have to kind of work within as they kind of do their bottoms up. But the outcome of that is a plan that we kind of lock in and kind of execute for the next 6 months. Now, people are kind of the engineers are kind of getting into the execution mode. And while that's happening, new supply is getting landed. It shows up in the data centers. And if you remember that whole pyramid picture, right? Like servers coming in, it gets powered up. There's a turn up that happens in there. And then those shared services get turned up. So those additional resources that you need, right? Compute and storage, they get turned up. And now those get available to us, our engineers, to kind of start using it. And then we track, like, okay, how much of that capacity is actually fulfilled, right? And the unifying metric here is OpEx, right? Like until we had that, we still did this process, but we are kind of shooting in the dark. We're just using a lot of judgment calls. But now we have real data. All the OpEx planning is done, OpEx dollars, the budget is there. We look at orders, yeah, there is a native unit of the resource that we have to order in, but we track what is the OpEx dollar of the orders that we are spending. And then same on the demand collection side, right? What is the OpEx dollar? Is it within budget? And then as the supply starts sliding, how much of the capacity that we had requested is getting fulfilled in OpEx dollars, right? So it's one metric which really streamlines our whole planning process end to end. So I'm going to talk a bit about like ROI-based planning. So now we have the OpEx dollars, right? So essentially the teams now estimate like what kind of incremental revenue, we call it IREV in short, for their projects. This gets reviewed and stack ranked. Now, calculating ROI becomes pretty simple. You know what the OpEx dollar is for whatever resource you want. You make an estimate of how much incremental revenue you can get. And you have the R and I is very simple. You do a stack rank of those projects. And again, there are other considerations as well, like Meta is in a very highly regulated environment, so there are regulatory requirements in different parts of the world. We have to kind of comply with that. There's privacy requirements. So we need to kind of plan for capacity. Not necessarily they will have an IRA, but those are very important projects as well. And then there are special projects, strategic projects, which may not yield like immediate kind of gain, but we still have to kind of plan for that because we'll get ROI for it in a year or maybe 18 months, right, later on. Now, all this stuff kind of gets put together, and that makes, because we are kind of dealing with this OpEx metric, it makes this kind of planning exercise much, much easier. I want to share another case study where having OpEx dollars actually really helped us solve a particular problem. In this case, we wanted to figure out what ads models we wanted to scale on GPUs. So we have this ML models, very sophisticated models we have developed over years. This is really the cash cow of the Instagram business. And they've been running on CPUs for a long time. And when GPUs kind of came a few years back, we figured out that, hey, we can actually benefit moving some of these models over to the GPU, increasing complexity, and that will drive actually better kind of outcomes, right? So there'll be kind of a real business value in terms of actual dollars over there. What we figured out is that as we kind of keep increasing the complexity, yeah, there is an ROI increase, right? Now, remember, GPUs are pretty expensive, so the cost that the incremental revenue you can get has to kind of account for the cost that you're kind of spending there. But there is a sweet spot over the time, like kind of the top of the curve, like there's an inflection point beyond which we found out that it's technically feasible to scale those models, but it's not benefit for you because you're going to spend a lot of money on the GPUs, but you're not getting that kind of ad revenue over there. So what we figured out is, hey, there is kind of a sweet spot, and having that OpEx metric help us make those curves. The other thing which we kind of figured out is that we have different vendors, hardware vendors, right? And one of the vendors is Meta itself. So we make our own inference and training chips. And each one of these hardware, they have their own performance per dollar characteristics, right? So they're kind of different curves for different kind of vendors. And that kind of helps us to really figure out like, hey, for a particular model, which one do we want to scale, how much do we scale it by, and on which hardware type, right? And that was all possible because we had that really kind of fine-grained understanding of the cost, right? And also, it also helps us to figure out like, hey, which models we just keep on the CPU because it's really not worth the cost of moving them, right? GPUs are too expensive. We just keep on the CPU and it works, well as it is. Going to talk a bit about efficiency. So as I kind of talked about earlier, it's a big company-wide efficiency program. And all the efficiency projects, the impact of the efficiency project, we want to capture in OpEx dollars as well, right? And that is like super useful, right? So when you're doing kind of planning, say, hey, you have a project with capacity cost like $10 million investment, but we could fund about $3 million in efficiency work, right? So then your net cost is $7 million. And that really changes your ROI story completely, right? Of course, there is a cost of actual headcount that you need to invest in to work on the efficiency, but having that common currency to reason about capacity cost, headcount, efficiency is actually amazing, right? You can actually make this kind of trade-off analysis decisions very quickly and really enables like holistic kind of budget planning, right? Also, there is a clear kind of connection between efficiency work and the incremental revenue that it drives, right? So we actually found there were like projects which we could do, like we didn't have the capacity, but because we invest in efficiency, we could ship it and it unlocked like revenue for the company. And that's really empowering for the teams to kind of see that connection, right? From the work they do at the on the efficiency work and kind of driving the value at the business level. Okay, we covered a lot of ground here. To just summarize, right? Meta is transitioning to ROI-driven capacity planning using OpEx as the key metric. We talked a lot about, how we develop this model, right? Really applying like FinOps principles at the data center level, really looking at comprehensive cost understanding, incorporating like all sorts of information, data center costs, server depreciation, rack level power, as well as personnel. Product teams like Instagram ads, we are using this metric for doing our ROI-driven capacity planning, right? We are really empowered to kind of do that and make the trade-offs that's required between capacity, efficiency, and headcount to optimize the business outcomes. I would also like to kind of give a shout out to the FinOps for data center and the focus initiatives. A lot of our work that we are doing at Meta is really aligned with that, and we are really looking forward to partnering with the FinOps foundations on these initiatives. So with that, we come to a close to the presentation. I'll open it up to questions.
Thanks both, very interesting. Quick question from my side. What do you do with unused capacity? Do you charge that back to teams as well, or do you take that centrally?
Yeah, so it depends on like, yeah, you have a budget, you get the capacity use, you have to pay for it, right? So, and that often happens, right? We try to be as accurate as possible, but we have some buffers and there is unused capacity and we have that. Now, the way we kind of manage that is there is that whole efficiency thing that's kind of happening. There's a continuous thing, right? So, we kind of put this thing in, we thought we'll use X units, but we end up using 0.9X, and we can actually reap that or repurpose that additional capacity for some other project, right, later on, right? So there's a continuous process that kind of reaps that unused capacity and for other projects in the following half. So that's the way we manage. But you still have to pay for it, right? We still have to pay for it. If like it's assigned to you, even if you keep it idle, you still pay for it.
And to add a little bit to that is there's part of the capacity committed to a product and product's not using, but there are also a portion of capacity Infra on. For example, we have to have more service to deal with like disaster recovery, all this kind of purpose there, which are not really intended for product, but we have to have them. In that case, right, there are two methods there. One, simple, we allocate them down to every product who's using it. That's the most simple way. But in this case, we actually think Infra should also be responsible for keeping the capacity lean. In this case, we actually treat Infra as a special product there, so that those spare capacity are actually attributed to Infra. And there's also another effort, just like a Cloud Spot instance there. This spare capacity are actually repurposed there by those low SLA jobs. So there we're still making full utilization of them.
Yeah, that's a good point. So one of the things we have a service like, think of it like Spot jobs, right, in AWS. So we have an elastic compute tier. So when we have like this is kind of at the platform level. So we have unused capacity, which can actually be used, and that's another way we can use it. But that is at a shared services level that we talked about.
Sorry. So looking about 5 years out, where do you see the mix changing for the percentage of computation being done in CPUs versus GPUs versus FPGAs versus ASICs?
Okay, so question is, what is the trend in CPUs, GPUs, and special purpose like ASICs? Like that's what we are saying. Yeah, so I think the trend here is, yes, I think there is a CPU footprint. Lot of our like expense as it grows is coming on GPUs, and we have a multi kind of vendor kind of strategy. We definitely at the company level, we will be investing a lot in our own ASICs. So we already have a training and inference GPUs, and there's a kind of a pretty solid kind of roadmap for that. Because and again, it's all about the cost, right? Like I think it's kind of managing that, and we figured out like for certain workloads, it actually makes sense to kind of build it ourselves. So I can very well see like there will be a mix of things. And it's about like having those options, right? It's not that we can serve all our needs with our own kind of internal kind of chip. I don't think that's feasible, but it'll be a mix, right? So we can make the trade-offs of what is available from different vendors. There are certain particular workloads, like some particular GPUs are much better suited. We may not kind of choose to invest in solving for every problem, but it'll be a mix of things. So that's what I see. So I think like in 5 years, I would see there will be kind of a more significant shift towards like more share of our internal kind of chips. We are just kind of building that out. I would see kind of a bigger portion of that being used over there. CPUs will remain the way it is. We have a multi-vendor strategy. I think that is fairly stable, but there will be a lot of improvements and I think expansion on the GPU and the ASICs that in the next few years.
Hey everyone, producer Andrew here. Thank you so much for watching and for your support. For more FinOps X 2025 content, go check out our YouTube channel. Like, subscribe, and leave comments and questions for all of our wonderful speakers. We appreciate your support.